Hey everyone, and welcome to another video. In the previous video, we looked at the differences between server-side rendering, client-side rendering, and pre-rendering or SSG. We're taking this further in this particular video in which we are going to do a deep dive into the defer block. So let's talk about what the defer block is. I'm going to quickly explain it, but then we are going to go into practical example. So previously in Angular, when you wanted to lazy load anything or lazy load a component, so to say, the only way we could do it was with using this load component or load children, which would essentially lazily load the module, and that is the only way. By that I mean that you could only lazy load pages. But what happens if I wanted to load something within a singular page lazily? That means not an entire page to be lazily loaded, but particular chunks or components to be lazily loaded. That is what the defer block allows us to do. And in a nutshell, the defer block looks like this. You have this block from the new Angular control flow. So you use the defer block, and in the curly braces, you essentially mention what is the component that has to be lazily loaded. In our case, let's say we are talking about this app heavy widget component. And until this component is loaded, you're going to show a placeholder right here. This is really helpful for showing skeletons or let's say a placeholder image until a real image is loaded. So there can be many use cases for this one. Now, when we talk about the deferred block itself, there are many ways that we can defer a component based on different triggers, and we are going to go through them one by one. But first thing first, if you want to follow this particular tutorial with a hands-on example, I would encourage you to go to this particular repository that you can find in the description of this video, and then make sure to give it a star and fork it. Once you have done that, you need to clone the repository. So just click here, copy the URL from here, and then you can go to your favorite editor. After you have cloned it, make sure to open the terminal, then run npm install. So that should install the dependencies. After you have done that, I want you to switch to a particular branch, and that is the defer start branch. So go and do git checkout, and then here you can say defer-start. Once you do so, you're actually ready to go. Now what I'm going to do is I'm going to run npm start in this case, and once the project starts, I'm going to show you what happens. You essentially get two different bundles. You get the browser bundles, and then you get the server bundles. In the browser bundles, you'll see that we have the styles.css, main.js, a chunk file, and then polyfills.js. In the lazy chunk, the only thing that you see right now is the products, and this products is essentially what we have defined in our routes, the lazily load route named products. So if I try to go to localhost 4200 now in my browser, you'll see that we are going to be automatically redirected to the products page. And there you go. You can see that we are loading the component right now. And if I scroll down, you'll see that we have a list of products that we can see here. If I click a particular product and do add to cart, I can see the title up here. Seems good. However, only this page is being lazily loaded, but my component right here is really heavy, and I want to lazily load this component, and I'm going to tell you why. If I go back to my terminal here, go a bit down, you're going to see something interesting. You're going to see these logs. First, we have app initialized. This essentially runs when we have our app component having the ng on in it. So whenever the app is initiated or the component is initialized, we essentially see this log. Since you see it right here, this essentially means that this component is being initialized on the server side, and that is because if we go to app route server.ts, you're going to see that the render mode here that I've set is server, which means that whenever you go to the application, it's going to render everything on the server. Then it would send the HTML back to the browser, and then the browser would also run the code again. So the app is going to be initialized on the browser as well, which is going to continue from where the server left off. So we see a log right here. Then we see a log that says starting heavy computation. This comes from our component that is called products list. If I go to the product list component, I've manually put something deliberately here, which is this heavy computation function. So whenever this product list component is initialized, or we run the constructor here, it runs the heavy computation. We see this particular log. It runs a really big loop, which essentially blocks the JavaScript thread, and then afterwards it just logs this thing right here. So this is happening right now in two different places. It's happening on the server, and it's also happening on the client as well. If I go back to the browser now, you're going to see that if I go to the console here, we also see the same logs. We see first app initialized, then we see starting heavy computation, and then we see the log here as well. as well. Now, all of this is just to simulate what happens if we have, for example, a landing page that has a really heavy component. And by heavy component, there could be many things. It could have a lot of processing. It could have a lot of images that are too heavy. It could have a lot of JavaScript involved in it, something like a jQuery carousel or whatever. First of all, don't use jQuery in Angular application, but let's say you have a carousel or some plugin that has really heavy JavaScript going on with that. But the fact is that when the user lands on your page, the only thing that they see is perhaps a simple text. They don't really see the components which are down on the screen or down on the web page, and there is no point in loading all of those components until the user goes there. Or there could be more complex conditions where you want to say, hey, I'm gonna lazily load this component when this happens. And for that particular matter, we are going to use the defer block. But before we do that, I'm going to show you the impact it does when we optimize for better user experience and also for performance. So first of all, I'm going to go here in the Lighthouse extension that is built in the Chrome DevTools. So I'm going to go to Lighthouse here and I'm going to do analyze page load. I have chosen desktop right here. So I'm going to let it run for a while and we'll see what the performance comes out of it. All right, so we have the results now. You can see that in terms of SEO, best practices, accessibility is good, but the performance is really bad. Well, the SEO is really good because we get the whole template rendered on the server. So we are not having an empty HTML, and you can refer to my previous video when I talked about SSR versus TSR versus SSG. But essentially, when the server sends back the complete rendered HTML, the search engines, web crawlers can read them well, analyze what are the important headings, what are the tags, what's more important about this page, how to search index it well, etc., which essentially increases the SEO. So that makes sense why it's okay. But the performance is really bad because if I scroll down, you're gonna see that here in the screenshots, you can see there's a huge time where we have just a blank screen. And that is because as soon as the app renders, we have that heavy computation kicking in, which blocks everything from rendering in the first place. And then at the end, somewhere we get something to render. If I scroll above here, you're gonna see that we have some indexes that are failing. For example, the speed index here is +3, which essentially means that it's more than 3 seconds. And according to multiple surveys, multiple researches, and multiple analysis by the Chrome team, if the search index is more than 3, then that really means that the people are going to drop off from your website and the conversion rate is really low. Having said that, let's also have a look at the other metric which is really important, and that is TBT, which is total blocking time. So total blocking time here is big. Let's see how big that is. So here you can see that it is about 2.5 seconds. So it blocks the whole thread for 2.5 seconds for running that whole for loop. And also you can see the speed index here is 3.1 seconds, which is what I said is much more than what we really need. If you scroll down and if you have not used Lighthouse, you can essentially see what are the improvement areas, how you can fix those. But I already know that we have an issue, and that is we are running everything, or we are loading the component even when it's not in the viewport, or we are loading it eagerly and we want to load it lazily. That's the whole idea. So we are going to do two improvements right here. One, I don't really want to run this heavy computation on the server. Let's say this was only intended for the browser, so I'm not going to run it on server. And second, I'm going to lazily load the component, of course. So I'm going to go to my code now, and first let's avoid having this run on the server. For that, what I could do is instead of running in the constructor directly, I could use the after next render in the constructor itself. And what this essentially does is that this only runs in the browser and it will not run on the server side. So I'm going to quickly paste this right here, save this. You can see that now we only see app initialized. We don't see the other one right here. And if I go to the browser and refresh, you're going to see that we get the HTML really quickly, and then it gets blocked with this heavy computation. But we get the HTML from the server really quick. And we can look at that in the network as well. If I go to the network tab and if I go to all for the filter, or actually go to the dock here, and if I refresh now, you're going to see that in just about 27 milliseconds, we get our HTML back. Now let's change that. I'm going to actually revert my change that I just did. So we have this running on the server as well, which means that we are going to run the heavy computation on server. So if I save this and if I go back, you're going to see that now it's pending and it's loading, and it took about 4.5 seconds to just come from the server. So it takes a lot of time because the heavy computation is running on the server. It can't really send back the rendered HTML. So once that is done, then it sends back the HTML. So we are doing two improvements, as I mentioned. The first one is just to run this on the client or on the browser, and the second one is lazy loading. So this is the first improvement, and now you can see that it just took like 59 milliseconds, which is good. Now to lazily load the component, we are going to use the defer block. So what I'm going to do is I'm going to go to my code here, and I'm going to go to the page component, which is products. So I'm going going to go to products.html here, and I'm going to close this for now. Now what I can do is I have this section here which basically checks if the products are loading, which means if we are loading the JSON which contains all the products information like their images, titles, etc. We are showing the loading indicator when it's loading. If we have an error, we show basically this. Otherwise, if we have the products, which means the products resource has value, then we render this component. But I'm going to render this still with a defer. So here I can use the defer block, and I can go here and just paste it like this. Now I'm going to save this, and for some reason with Prettier and ESLint, you can see that this gets formatted really weird. So I'm going to try to do this again, but a bit nicely. And I'm going to save this without formatting now. I'm going to do Ctrl+Shift+P, save without formatting. And now I can go to my browser, and you can see that we still got this start heavy computation, right? Now if I refresh now, you're going to see that still we have this computation happening. The UI gets blocked for a bit. But if I go and try out Lighthouse, let's see what happens. I'm going to go and clear this, and I'm just going to run analyze page load again. All right, this time you can see that the performance actually decreased. And this is the point where I want to tell you that you will not be trusting Lighthouse when you're running it on your machine. And that is why when we are running Lighthouse in production via the CLI or the SDK, we don't really just run one pass. We essentially run it multiple times, and then we take an average of it, because it really depends on what your machine has in terms of configuration, also what process are running, how much RAM is free, CPU is free, etc, etc. So we're gonna have to run multiple times. But if I scroll down, you can already see that the speed index is now much better, and the total blocking time is still bad. So if I come down here, you can see that the speed index here is 1.3 seconds instead of what we had 3.1, and the total blocking time is still there. And the reason for that is that it is still running the heavy computation as soon as possible, because what happens is when I use defer with nothing, then that really means I'm using defer on idle, which means that the browser is going to start loading the JavaScript as soon as it can, and it's going to render the component also as soon as it becomes idle or has some space. We don't really want that. We want this to happen when the user goes to the particular component and goes to that section. So I'm gonna use on viewport in this case, and when we use the viewport here, we have to define a placeholder. So now what I can do is I can essentially use placeholder here, and for this I'm going to copy this app loading indicator from here, and then I'm going to paste it right here. Now let's quickly save this, and now when we go to our browser, let's try to refresh, and now you can see that we don't really see any logs at all at the moment. And if I scroll a bit down, now you can see that we start the heavy computation because we have this in the viewport. We show the loading screen, and here now we show the component or the products, which means that if I now go to Lighthouse and run this again, we'll have much better metrics. So I'm going to quickly analyze the page load here, and let's see what happens. All right, so you can see that immediately we went from 50 to 90 score for the performance, which means that we are not really blocking anything at all. If I come here, you can see that the total blocking time is still a bit. If I come here, you can see it's 250 milliseconds, but we see the content right away, and this is what we want. We want the user to see the content as soon as possible. We want no cumulative layout shift, which means that the UI should not jump around. We also want the largest contentful paint, which means the largest item in the screen that should be rendered really quickly, so it doesn't take a lot of time. So no heavy images, etc. I'm not gonna do a deep dive on performance or the Lighthouse metrics, but you understand the idea about just by deferring correctly, we have a boost in performance, and only when the user goes to the heavy component. And again, obviously you are not going to be running a heavy for loop on your components. It might be doing something else, would it still be heavy. You may not have a stuck loading indicator on your screen, but still a heavy component loads later on. Now, one thing that I want to show you here is when we talk about the defer loading, what should it technically do? It should actually do two different things. It should load the JavaScript bundle when the deferred trigger happens, and it should also render the component when the trigger happens. So it should load the JavaScript, it should then start executing it, which in turn would render your component. Now with version 20, the first thing doesn't really work, which means that the JavaScript bundle that has this lazily loaded component still gets loaded early. Even though it doesn't start executing early, the bundle itself loads a bit early, which doesn't really affect the initial performance that much, I would say, because it still doesn't execute, but still it loads the bundle, which is not what we want. So here you'll see that we have a bunch of chunks. We have this particular chunk which contains product list for template that you can see right here, and this is the product list component. Now even if I've not scrolled to the page, this bundle is loaded. Why is that happening? And that is because there was something that was introduced introduced in version 19.1, and I found it out when I was actually working on this particular video. I saw that this is something that probably should not be happening. I actually was trying to see if I'm going insane or if this is actually how it should work. But when I tested it multiple times with different triggers, etc., I figured it out that it's a bug. I reached out to the Angular team and they actually helped me create this particular ticket, which basically addresses this issue that the deferred chunks are being preloaded when they should not be. Well, why does that happen? If I right click and go to view page source, you're going to see that here we have this chunk right here that is being loaded, and it has this thing called module preload. And when we have a look at the same chunk, which is this MGB, if I go here, it is the same one here, and this is being preloaded even if this is a deferred block. So we don't really want this code to be part of this particular chunk, which is eagerly loaded. And Jessica from the team basically created this issue and also linked the stack blitz that I created for just showing that this is a problem. And then we have had a quick discussion around this, but I'm hoping that this is going to be fixed pretty soon. But ideally, the deferred block and the JavaScript bundle should be loaded later on. But to make this video even more interesting, I'm going to show you how it should actually work. So what I want you to do is we're going to discard our changes, what we have done, or stash them. And then we're going to another branch that it has Angular 19.0 prior to this bug, or when this bug was introduced in the Angular ecosystem, which was 19.1. So what I want you to do is to do git add dot, then you can do git stash so we don't lose our changes. And then what we can do is to switch to git checkout, and here we can say defer start and then v19. When you do so, your branch will switch to v19, and then you have to reinstall the packages or reinstall the node modules. So what I'm going to do is I'm going to quickly go ahead and say npm install -- legacy peer deps. I'm running legacy peer deps because we are using Tailwind CSS 4, and Angular 19.0 sort of has, or the builder has, Tailwind CSS 3 as peer dependency for some weird reason. But if you run npm install, it's going to fail. So we don't do that. Now I'm going to do npm start right now, and I'm actually going to show you something that I forgot to share. So let's go to the browser again, and you'll see that the application here would also work quite the same. Right now, it's trying to get the products from the server. Then you can see that we see this start heavy computation. The difference that we have right now here is that the defer actually runs on a timer. I'm going to change this to viewport just like we had before. So I'm going to quickly run this, and then for the placeholder we need a single tag. So I'm going to actually put this inside a div like this, and we're going to say save without formatting. We're going to go to the browser now, and I'm going to refresh again. Now you're going to see that this loads pretty quickly. We don't have any computation going on unless I go down. But if I now scroll down, you're going to see that the JavaScript bundle is going to be downloaded now. So if I scroll down here, you can see that this chunk got loaded. If I open it, you can see the same code here. So it's the for list, for template, etc. So you can see exactly the same thing, but the chunk is being downloaded later when the deferred trigger happens. So this is just important to know that this issue was essentially introduced in 19.1.0, and this was basically introduced when the bundler tries to preload all the components or all the routes, so to say, that are marked as module preload. And right now the deferred block are also marked as module preload, which should not be the case until we do prefetch, which we are going to talk about later. But now you know that ideally the deferred blocks bundle should be loaded later on, and the component should also be rendered later on. So I hope that this gets fixed, and you'll see when this gets fixed. Now I'm going to go to the v20 branch again. So before that, I'm going to quickly discard any changes that I've done. So I'm going to reset this, and then I can go git checkout defer start. So we are at the right branch. Now I'm going to run npm install. So we install the correct packages, and now I'm going to do git stash pop. So I have my changes back here. All right, so you can see that the code looks correct. Now there was something that I wanted to show you before and I did not. So previously we ran npm start, right? And when you run this, you're gonna actually see a warning that I did not show you before, and that is right here. You can see that it says Angular has detected that this application contains deferred blocks and the hot module replacement is enabled. All the deferred block dependencies will be loaded eagerly. Now what this actually meant is that there was only one chunk created when I refreshed. So even though we have a lazy chunk for products, the products page or the product list and the products page, everything was essentially bound in this one chunk. It contains the services, it contains the products component right here, it contains the product list component and whatnot. We don't really want that. So when you're running this in dev mode, you may want to disable the hot module replacement so you can actually see the chunks that are being created and loaded. So what I'm going to do is, instead of running npm start, which just runs ng-serve, I'm going to run ng-serve --no-hmr. So when we run this, now we're going to have a separate chunk for the products page and also for the product list component, which is supposed to be lazily loaded. So here you're going to see that we now have this product list as in a lazy chunk. So we got two different chunks now, and we got products here. Now if I go to my browser, you can see that we have two different chunks, one containing everything that it needs in the beginning. So this contains the products page because that's the first page that you go to, so it's loaded eagerly in that particular sense. But the second chunk contains the product list 4, or this particular component, which is essentially the product list that we wanted. So even though we are running the no HMR with the bug that we had right now, we still get this chunk preloaded. I wouldn't say eagerly loaded, but I would say preloaded, and when they fix it, it's gonna be fixed. But even though if this bundle is loaded, it's not executed until I go down and then it gets executed. So for the rest of this video, I want you to just forget that this bug exists. We are only going to talk about how do we defer based on different triggers. And the first trigger that we have seen is on viewport. So when you don't have something in the viewport and when you scroll to it, then essentially this gets rendered. And you can also see that within the Angular DevTools, and I would highly recommend you to download the Angular extension for Chrome DevTools. If you have not already done that, you can just Google it, and then you can see that this defer block has this app product list. Now if I scroll up here and refresh now, you're gonna see that we do have this defer, but what does it show? It shows the app loading indicator. Well, why does it show the app loading indicator? Because if I come here, you can see that the placeholder that we show here is app loading indicator. Well, let's change that. What I'm going to do is I'm going to put the same thing as we did before. Here I'm going to say that this is a placeholder. So I'm going to quickly save this, and now I can come back here and you can see that now it just says defer placeholder, and this defer doesn't really have a component, it just shows a simple text. If I go to the elements here, you can see that the element here has the products page. Inside that you can see our products, and then this section, if I come here, you can see the placeholder being shown right here. If I scroll a bit down, you can see the placeholder here, and now it's loading. Once it is done, then you see the components right here, or the products right here. Now we've talked about the viewport. We also have something called timer, in which you can give a timer in milliseconds or seconds. So I could say 300 ms, which means 3 seconds, or I could just say 3 seconds, which means that if I go back to my page here, you're gonna see that after 3 seconds, it's gonna automatically start the heavy computation. So timer means that it doesn't really matter that if it's on the viewport or not, it's going to still run it after the timer. So if I refresh now, I don't even go to the viewport, it's gonna still take 3 seconds, and then we'll start executing it, and then we'll show the logs. And if I scroll down, you can see the products already there. As I mentioned before, if you're not providing anything to defer, that means that it uses on idle by default, which means it's just going to load it as soon as possible. Then we looked at the viewport. We also looked at timer. We also have something called immediate, which means that when the whole content is rendered, which are non-deferred, then it immediately renders this deferred content. So this is a bit different from browser idle. The browser could be doing some things and it's not idle, but immediate means that it would still render the component even if the browser is not idle, but it has finished rendering the rest of the content. And now we can look into interaction and hover. Both of these essentially mean that if we are interacting with a particular component or an element, then it's going to work for us. So here we have, let's say, a large component, and here we have a div. We would load this defer component if there's a click or key down event. So here you can see that when the user interacts with the specified element through click or key down events, which means that the placeholder could have something that has a click or key down event. And that's what we are going to do. Instead of this placeholder just having a text, we are also going to add a button here. So let's quickly add a button. We're going to do a class here. We're going to say button accent, and here we can say load products, for example. Now, before I save this, I also want to change this to interaction, which means that interacting things in the placeholder. Now I'm going to go to my browser and I'm going to go to the app now. You can see that now we have the page loaded. If I scroll down, nothing gets loaded at the moment. If I try clicking this, you can see automatically that this starts a heavy computation, which means that clicking the button essentially triggers it. And this would be the same if we had a key down. Now, another thing to note with these triggers that have interaction on hover is that you can tell, apart from the placeholder, which particular element we are talking about. So instead of having something in the placeholder, you can essentially give this a template variable. For example, let's say this placeholder did not contain this this load products button. So I'm going to actually remove this now. And the section up top, we go ahead and we paste this particular button here actually. Now, when we talk about interaction here, we can give this the variable. So let's say we say load button, which means that this button should have the template variable called load button. So if I save this now, and if I go to my browser, you can see that we do have the load products right here above the placeholder. Now you could have it right here as well. It doesn't really matter. So when I click load products, and I actually don't like it, so I'm going to actually change this a bit. I'm going to remove this button from here and put this right around the settings here. So let's put it right after products heading. So here you can see we have products and we have load products right here. We could maybe make this a bit better by just saying that this is a flex and have a gap 4, and then the button could be wrapped inside a flex 1 just like this. And if I save this now, flex and justify and as well, this looks much nicer. So if I go with this one and if I click the load products, you're going to see that we see the start heavy computation. Sorry for the CSS, but I can't help because I'm a front-end developer. So now that we have this and my eyes hurt watching this not being aligned, I'm going to actually have to go here and do items center. So this looks aligned properly. Thank you so much. All right, so now we know that we can use a particular button or a particular element to load something lazily using the defer block. But what about our next trigger, which is hover? So we're going to look at hover as well. This also does the same thing. You can either have a placeholder on hover of which this should render, or we could have an element here as well. So what I'm going to do is I'm going to change the trigger from interaction to actually to having hover. So I'm going to quickly change this to hover, save now. And again, I want to save without formatting. So this actually looks a bit better. And now this looks much better. So I'm going to do save without formatting. Now, when we go to our application, you're going to see that here, if I just mouse over this, you can see that we have start having computation. So it automatically does it. So you can have different triggers to load your component lazily. Now we can talk about another thing, that is when. And when is used when you can actually define a particular custom condition, which is a JavaScript statement in this case, and that expression is essentially going to load the component, and you can have a placeholder with that as well. So what I'm going to do is I'm going to go to my code, and in here, instead of on hover, we are going to essentially go ahead and say if the product has value, so to say. And by that mean, I think we can just remove this particular condition. So I'm going to remove this, and then I can quickly go ahead and show the value like this. And with this flow, we are saying if we are loading, we show the loading indicator, and this is talking about loading the product's JSON, not really loading the deferred component. Then if there was an error fetching the JSON value, then we show this. Otherwise, we defer, which means that there was no error, it's not loading, and that means we should have some data. So here we can say when we have the product data, then we essentially go ahead and we use the value right here. And now you can see that the products here is not really happy, and that is because we are not really having that particular guard of has value, which usually comes handy with the if condition. So what we are going to do here is that we are going to essentially put a conditional empty array here as well, because when this condition is fulfilled, we should have some value here. If we don't have a value or that's undefined, then we just fall back to empty array. Now, ideally, it should still contain the value. So now we have a when trigger. So I'm going to actually save this now and go to my browser, and you should see that immediately it starts having this heavy computation, because when we go to the network tab, you're going to see that if we go to XHR, this happens really fast. So it has like 9 milliseconds. So if I just refresh now, we got the JSON, and you can see it started the heavy computation. But if we had some delay or we had a slow network, then it would take much more time, and then it would essentially show this later as well. So what I'm going to do is I'm going to go ahead and throttle here. So I'm going to change from no throttling to, let's say, 3G. Now let's refresh now, and we are going to see how much time this product JSON takes. So I'm going to refresh now, and now you can see that we are not really showing the products anymore. And now you can see that it started fetching the data, and now it started the heavy computation, and that happened quite a long time later. And again, here you can see that this particular request essentially started somewhere around 55 seconds or 45 seconds, so to say, here, and then it took about 2 seconds to download. But until this happened, we did not really render the component ourselves. Right now it's downloading the images. I think if we switch to no throttling, they should be here by now. So yeah, you can see that we can put specific conditions using the when keyword. Now that we have discussed the trigger
triggers, I want to put your attention to a couple of blocks. So we already discussed about the deferred block. We already have seen how the placeholder works. So when the component is not shown or it's not rendered, we will still show the placeholder. But when we are loading the JavaScript bundle for this component, then we show the loading. And again, this loading is different than loading the data. So it's not loading the data, it's loading the JavaScript bundle. So when you want to show a loader while the JavaScript bundle is being loaded, you can essentially use the loading block just like this. And if for some weird reason your JavaScript bundle could not be downloaded and there was an error, then you would use this error block. Now this could happen when you have your server down or you have your CDN not working. So in those particular case, you may still want to show the error here. Let's take a quick example for the error itself. So I'm going to go here, and if you want, you can essentially add the loading here as well. So I'm going to quickly go ahead and first add the loading one here. So I can say loading. In the case of loading as well, I'm just going to go ahead and show the app loading indicator like this. And then in the case of error, we're going to just say failed to load large component or failed to load products component. Now, how can we test this? I'm going to quickly save this, go back to the browser, and now you can see that it's doing starting heavy computation. What I'm going to do is I'm going to go to the network tab here, and we're going to identify which is the chunk, and it should be the second chunk usually. So if I scroll up here, I can see the product list. So what I'm going to do is you can right click here and then you can say block request URL. When you do this, it's not going to be able to download that particular chunk. So if I'm here and if I refresh now, you're going to see that it says failed to load products component, which is the error. Again, you may want to make it a bit better. So you can add class alert error just like this, save this, and now you have it much nicer. So you can see failed to load products component. Great. The final topic of this video is prefetching, and prefetching will not work until the bug that I mentioned has been fixed. So if this is not fixed, there's no point in prefetching or using this, because what's happening right now is that it's doing prefetch on idle. So ideally what should happen is that until we use prefetch, it should work as it was working in Angular 19, which means that if I say only render when you have data from the JSON, then the JavaScript bundle should be prefetched or should be fetched, so to say, when we have the data. So even the JavaScript bundle should not be loaded. But right now what's happening is similar to what you would do with prefetch on idle. When you put yourself this code in here, then it should preload or prefetch the JavaScript bundle as soon as possible. When would you want to use this? Let's say you already know that the user, when comes to the landing page, immediately goes to this particular section. If you already know that, then it makes sense to preload the components JavaScript already. Assuming that it's a big component, then it would take some time to download it. So when the user is here, let's say they are reading the important information here, during that time you already prefetched the JavaScript bundle. So when they go here, automatically it gets rendered quickly, so they don't have to wait at all. That really boosts the user experience and performance, of course. So you can use prefetch on idle, you can use prefetch on viewport. You can also say when the user has this particular section on viewport, prefetch the JavaScript bundle of that particular component. So you can even do a crisscross, so to say, so you can go really complex with the prefetching as well. So the prefetch supports all the triggers that the defer supports. So we have interaction, we have hover, we have other things as well, but essentially the keyword that you want to use here is prefetch, and you have to separate these with a semicolon. So make sure to do that. Now, before we wrap up this video, we need to talk about how does defer work in server-side rendering and static site generation, so SSR and SSG. The way it works is that the deferred block will do either of two things. One, it could render the placeholder, and second, it would not do anything at all if the triggers are not run. For example, in the case that we have right now, which is the when case, in this particular situation, it's not even going to render anything at all because this trigger never happens. However, if the trigger was different, let's say it was immediate or on idle, etc., then it would trigger on the server side as well. For example, if I just go ahead with doing this and then I go to my browser, and if I refresh here now and then I right click and go to view page source, you're going to see that here we should have this placeholder. Because it's on idle on the server side, essentially it renders the placeholder content there. But when we have a trigger like when or on timer, etc., then we won't see it. So if I go here and refresh now, you'll see that this time we don't have the placeholder content here at all because the condition was not met. I'm curious on checking the on timer actually. So let's quickly remove this. I'm going to do on timer, let's say 5 seconds. Since the server already should send the data back, I don't think it should render the placeholder even. So if I refresh now, go here, oh, it actually actually does render it. So in the case of on, it essentially renders the placeholder, but in case of when, it does not. Let's actually try one more thing. Let's say if I go and say instead of timer, I change this to on viewport. I believe in that case also it should render the placeholder. So if I refresh now, here you can see the placeholder. So that makes sense. I'm going to quickly go and change this back to the when condition. Great. Now I can essentially go back to my network tab as well and then make sure that I have these blocked URLs gone. So if I refresh now, I should be able to see the loading indicator and then the products once the computation is done. Finally, I would recommend you to look into the documentation itself because that's the best place to understand what's happening and why it's happening. I often obviously go to the documentation to understand myself how these things work. And as a front-end developer, I would highly encourage to look at the best practices for deferring views, like avoiding the nested defer blocks, avoiding the layout shifts. Obviously, if you want really good core web vitals, you want to have any layout shifts avoided, of course. And speaking of best practices, instead of rendering the placeholder, what if we wanted to render the actual content on the server? That is where hydration or incremental hydration comes in, and we are going to talk about that in the next video. So I hope you found this particular video helpful. It was a longer one, but I hope it was worth it. Let me know in the comments, how did you find this video? Did you like it, not like it? Do you like longer videos, shorter videos? And if you're excited about this whole phenomena of server-side rendering, hydration, the defer blocks, the possibilities that it opens up for developers to use and whatnot. And if you have not already liked the video, smash the thumbs up button, subscribe to the channel so you don't miss out any notifications for the upcoming videos in this particular series and the future series as well. And if you really want to get your Angular game to the top notch, look for my Mastering Angular Signals book, which should come out anytime soon. And obviously there would be a discount for the subscribers. So stay tuned and you can find the link in the description of this video. As always, happy coding. I'm going to see you next time.